Hello everyone, and thanks for watching my videos. This is my YouTube channel, Chemistry is Life -H2O. The name tells it all. Chemistry is our survival. Our body is running chemistry 24/7. Water, which is H2O, is our survival. We will not exist without water. I create this channel so I can share some interesting topics on general chemistry as well as physical chemistry. I'm very passionate about chemistry. I've been in the higher education for 20 plus years, and I am very passionate about what I do. I love what I do. And I wanted to create this channel so I can share my passion with a global audience and reach as far as I can reach. And I hope this will be beneficial to everyone who's watching my YouTube video channel, YouTube videos. And again, if you like my videos, don't hesitate to subscribe, hit the like button and the notification bell so you will get notified once I upload videos to the YouTube channel. This is something new for me. It's a new adventure, and I look forward to grow this channel. I look forward to upload more videos, as well as maybe in the future even do live streaming. And thank you so much for your support. Solution, the aqueous solution mean it's in water. So what's a solution? A solution is any homogeneous mixture that is physically and chemically the same throughout the whole system. A solution must have solvent and solute. In order to have a solution, you have to have two different components. In our case, the solvent is water. The solute can be any substance dissolved in water. And there can be more than one solute, as I explained yesterday. Here's different type of solutions by basically dissolving the solid in water. And again, you can see it can have different colors as long as it's homogeneous. As long as it's homogeneous, then it's going to be a solution. We looked also into the calculation in this chapter. As I mentioned, this is the equation. This is the main equation in this chapter. And this equation is the concentration. How can you determine the concentration mathematically? If you have different amount of the solute in the solution, that different amount is going to represent different concentration. So here is the equation, the molarity, which is the expression of concentration, equal moles of solute per liter of solution. The moles of solute, we know how to calculate the number of moles, which is mass divided by molar mass. The volume has to be in liters. How many grams of solute would you use to prepare 1.5 liter of 0.25 molar glucose? You have the formula. So what information do we have? We have the liter of the solution. We have the molarity. So I have these two. I'm missing a third. So in this equation, you'll be always given 2 out of 3 unknown. So how we get the number of moles? The number of moles is molarity times volume. The molarity is given, the volume is given, we'll get the number of moles. How you get the mass? Multiplying the number of moles times molar mass. So multiplying the number of moles times molar mass, that will get you the mass of sugar. So in this case, all what we need is 67.5 grams of glucose. We're gonna weigh this at the balance. So this is how we make the solution in the lab. Weigh this at the balance, and then we dissolve it in a total volume of 1.5 liters. And that will give us a concentration of 0.25 molar. How about if I want to dilute this? How about if I want to perform a dilution? Meaning I want to take certain amount of that solution and add another amount of water to it. So that will be a dilution process. You take the concentrated solution, you add more solvent, that will be dilution. Excuse me. Here is the equation that we'll use. We have initial condition and we have final condition, MIVI equal MFVF, where M is the initial concentration, VI is the initial volume, MF is the final concentration, and VF is the final volume. You'll be given 3 out of 4. Here's an example showing you how to use this calculation. Sulfuric acid has a concentration of 18 molar. So that's the concentrated solution of sulfuric acid is 18 molar. You want to prepare 250 milliliters. So that's your final volume. And you want to prepare 0.5 molar of sulfuric acid. That's your final concentration. So 18 molar is your initial concentration. 250 milliliter is your final volume. The 0.5 molar is your final concentration. What are you missing? The initial volume. How much you need to get out of the concentrated bottle. To do that, you will do again MIVI equal MFVF. And from here, your initial volume is MFVF divided by M initial. M final is 0.5. M initial is 18 molar, and your final volume is 250 milliliters. If you do the math, your answer is going to be 6.94 milliliters. All right. So since we're dealing with a solution, there is a very important fundamental, which is electrolyte versus non-electrolyte. How you define a substance to be electrolyte, how you define a substance to be non-electrolyte. How you define a substance to be strong electrolyte, how you define a substance to be weak electrolyte. So, in general, ionic solids and some polar compounds such as strong acid and strong bases is going to be treated as strong electrolytes. And they're going to have high solubility in water. So strong electrolytes have high solubility in water. And what does an electrolyte mean? Electrolyte mean it will conduct electricity. So if you have wires going through the solution, these wires basically will able to conduct electricity through the solution and will able to light up a bulb if you have a bulb at the end joining both wires. All right, example of strong electrolytes: sodium chloride, which is ionic, potassium hydroxide, which is a strong base, hydrochloric acid, which is strong acid, nitric acid, which is strong acid. So strong acid is strong base, and ionic solids are classified as strong electrolytes. So why the electrolytes conduct electricity? Because the electricity is carried by the ions in solution. A strong electrolyte produces ions. The non-electrolyte does not produce ions. The non-electrolytes, which is covalent systems, they just dissolve. They don't dissociate. Sodium chloride will dissociate into ions, sodium ion and chloride ion. And this is very important for the fundamental of the solution. When you say dissolve, this is different than you say dissociate. When a substance dissolve, that means is mixed with water. It's not necessarily it's gonna dissociate. When a substance dissociate, that means it's producing ions. So which substance is going to dissociate? The strong electrolyte. Strong electrolyte will dissociate 100%. When this arrow going one way like this, that means it's 100% sodium ion and chloride ion. So the salt that we add in our food, when we digest that salt is not digested as sodium chloride. That salt is digested as sodium ion and chloride ion, which is known as electrolytes. So positive and negative, this is how they exist in the solution. Because again, you can see they're not dissociating to 100%. Look at this arrow here. You can see this arrow has two ways. One way is giving you ions, the other way is giving you the undissociated form. And you can see the arrows going back is much, again, higher in production of the undissociated versus that. This is a one-way. This arrow here is a one-way. So in chemistry, arrows mean a lot. Arrows mean which direction is your process is going. When you see an arrow like this one way, that means your process is going toward the product. When you see two half arrows like this, that means partially the process going one way and the process going other way, the opposite way. Which one has the highest chances is the one that has the highest. As you can see, the length of the arrow is going toward the undissociated. So anyway, don't just put too much energy into that, but basically simply saying, looking at this is a partial dissociation. Looking at this is a complete dissociation from just looking at the arrows. This is a complete dissociation. This is a partial dissociation. If you have a partial dissociation, then this will be weak electrolyte. If it's weak electrolytes, will not conduct electricity, again, as I said, as strong electrolytes. So here is the weak electrolyte. You can tell the light intensity is lower compared to a strong electrolyte. You can see the light intensity is much, much higher. Look at the non-electrolyte, there is no light intensity at all. There is no electricity going through the solution. And here are the examples, again, water, alcohol, again, sugar, all of these are non-electrolytes. Weak electrolytes are weak acids and, again, weak bases. Here is, again, highlight of the table one more time, was magnifying on the difference, again, between strong, weak, and non-electrolytes. And you can also look at even the image of the, so here is how the strong electrolyte will be. You will have positive, negative. The weak electrolytes, you're going to have some of them, so they don't have positive, negative, all of them. You can see some of them is undissociated. The non-electrolytes, you will not have any ions. There's no ions produced in the non-electrolytes, and that's why there is no electricity. So again, so the image also shows which one is strong and which one is weak and which one is not. So if I give you image with these like this, and I ask which of the following is a strong electrolyte, you can basically tell which is the strong electrolyte by looking at the image showing the dissociation. This one has complete dissociation. You see here, you don't have any undissociated. This one has undissociated, so this is weak. Why it's not? Why is not non-electrolyte? Because it has positive and negative still. Very small amount, but still has positive, negative. This one has no positive, no negative, so there's no dissociation whatsoever. So this one is non-electrolyte, this one is a strong electrolyte, and this one is weak electrolyte. So from the image, you should be able to tell, you can know by now, that we can present any system in terms of graphical representation, and you should be able to identify that.